Yeah, also Git is subjective here. I'll talk about that more like here, but basically I guess first, you shouldn't take anyone's opinion without just considering what they're taught, what they're saying, because coding style is very subjective and everyone's just drawing from their experiences. There's no one right way to do code or to build an application or anything that you'll do with coding. It's more of a creative thing. But we all have experience, and here's some of mine. So I started freshman summer. I started coding with 611 or 6100A my freshman spring. And then I got an internship at one of the startups freshman summer. And then I took web lab last year, and then this last summer, sophomore summer, I was working at Google, working on YouTube TV. And then this next summer I'll be at Stripe. So this is the experiences I'm coming from. And so I hopefully that gives me some credit, but it's mainly based on just what I've observed and how to code, but everyone else will have a different opinion. I'm sure if you ask 611, I guess the 6100 professor now, Adam Hart's, at least for me, he would have different ideas of how to code good for me. So just consider and compare it against your experiences before you take my everything that I'm saying. So first thing that we should ask is why code Git? So the reason why you want to consider coding practices when you're making your applications or for the beyond web lab is having correct developer practices makes your code more readable. So so it saves time. You'll actually understand what you're doing. Makes you easier to work with, so people will want to work with you. Leads to less frustration while coding because you don't have to debug as often. And then for everyone taking this class, means that coding is more fun, easier to do, and then people, like I said, people like yourself will understand your code. And if you're a professional developer planning to be or considering it, all these mean lots of money, and all these mean whether you pass an interview or not, whether you get hired, how much salary you make, whether you get promoted or not. So these are literally millions of dollars. We're talking about over a decade or a lifetime if you master these. And so it's really, really hard to find good developers. So if you can do these well, then you will succeed in your career. So let's first go over some Git hygiene, just general Git practices. We'll review more of this on Friday for the part 2. We'll go over how to do a pull request and how to go through merge requests. Those words may not mean anything, or maybe something that you just learned last week, but we'll go over those, and those will be very useful. So first, before you start working, you always want to Git pull. Generally, so this is assuming that you don't have any active changes, but we'll go over that in a bit, but you shouldn't when you start working. So when you start working on a change, Git pull, make sure that you have your most up-to-date code. And just so that you don't run into any unnecessary merge conflicts when you're going through and starting to work on features. Now, before you commit, so let's say you add a lot of features, or just some, hopefully some, but then you're okay, let's try to commit this, right? So before you put these 2 commands, which may not do all the time, so you can do this with Git status. I'll go over some VSCode stuff, but I'm just going to go over the terminal commands first because that's what we've been teaching you all. But you can all do all this with VSCode. So Git status, what it does is it just shows you the current Git changes that you have on your local copy and your local repository, so that you know what you're actually changing, and so that you don't accidentally delete or add a file that isn't needed. So just make sure that you're aware of what you're doing before you commit. Otherwise, people will get mad at you usually if you delete one of their files, and then they have to go back on Git. You can also do Git diff, and you can see the individual changes for files. You can see here the README, you can see what added or specifically what lines were added and removed. And then you can also, all right, I guess here also, we'll start going over commit stuff. So do not do this. So this is And you see here that's in the syntax error, then like no daemon crash. For any error or like things that don't work, this is also a bad like git commit message, but the main thing is do not ever commit broken code to your repository, especially your main branch. So the only exception to this would be like, let's say you're communicating like with a teammate and you're like, okay, I have no clue how to solve this bug. Can you take a crack at it? And for that, you want to make another branch with the current changes, and then you want to push it to that branch instead of the main branch. And so because if you push broken code, then your project just breaks. And let's say like another person is working on a working version of the code, and you push broken code, then they have to go to a merge conflict, and they're like, if they merge the two things, then it'll just be broken. So that doesn't help anyone. And then here's some other stuff like when you're committing, like when you add like even if it's like a few lines, something like that, generally like you want to make your commits very small and focused and commit a lot. Don't be afraid to like commit like 10 times if like you're working on like a bunch of features or like adding a page. Like if you add like a function and you're like, okay, like this works, like I want to have people review it or something like that. Like don't, it's not, there's not going to be like any bad consequences if you commit a lot. And hopefully I would hope that people don't get mad at you. I don't know why people would get mad at you for committing a lot, but this is an ideal kind of commit message. So it says here commits out a single thing, it's focused and clear, and it's consistent with how your team company wants to like their commit messages to be formatted. A lot of companies, or I mean, you may or may not, but at least like from what I've seen, like there's a general format for how commit messages are. Like they may be past or present tense. They may like have a certain breakdown grammatically or something. So make sure that's consistent with that. And then like the reason why like it says here like avoid mega commits. I mean, that could be as small as like adding like 100 lines or something like that, or as big as like adding like 5,000 lines. But you want to focus, you want your commit message to fit in a single sentence. Well, not a single sentence, but like it can be just a simple sentence with no like ands like this. Like you don't want it to be fixed on and remove like sequence and remove SSR. You just want it to be a single subject. And the reason why like mega commits are bad is because it introduces a lot of points of failure. So if you're adding 5,000 lines of code, your teammates won't really have, like if they're trying to understand what you're doing, they'll be like, oh, this guy just added 5,000 lines of code or girl. But like, okay, like I'm not going to read through all this because this is way too much to read. Like, and so what's generally going to happen, like in companies especially, so when you commit code to production or like just the general like code base, like they'll hopefully have code reviews where generally senior people look at the code that you're doing. And so when you add a mega commit, like seniors' time is the most valuable and developer time is the most valuable like time in a company, or like, and it costs the most money. So when you're wasting developer time, companies will get mad, and also developers will get frustrated at you. And also, so like generally the two outcomes is when you have a mega commit, either they approve it and just like kind of gloss over it, or they reject it because it's way too much. In your case for like web lab, the general thing that's probably going to happen is your teammates will gloss over it, and you might miss a lot of bugs that way. And over time, I'll talk about tech debt later, but it leads to a lot more bugs than just committing once at a time. It makes it easier to understand. Here's some dangerous Git commands. So yeah, dot just adds all of the current changes that you have to your and stages them to your commit. So this can be kind of dangerous when like you create like a local file and you're like, oh, like I didn't mean to actually commit this. It just adds it, and if you're not aware of it. So like you're generally not like hopefully not changing too many files at once, to where like it might be like a maximum of like 5 files hopefully. And so this isn't too much, like it takes up like 30 seconds more and avoids a lot of headaches, potential headaches. The most dangerous commands ever in like Git is git push dash force. Never know unless you know what you're doing. And even like professional engineers who have been like 5 years of experience to do this, it's like a joke within the computer science community that like interns will just break code by doing this. Generally, like companies will not let you do this at all. So What this does is that it ignores all merge conflicts when you push to the branch. So it just takes your like local copy of your code and just pushes onto the branch. And this is really bad for obvious reasons, but you don't want to be overwriting all of the code with your own code that may be broken or anything like that. Git reset dash hard, we've already done this, but like we've done it. This is useful for workshops. Oh yeah. Yeah, so that's why, so the question is like, if you use git push force, is there a way to recover the previous version of the code? Well, that's why we use git. So like if you notice on your GitHub, there's like commit IDs at the top of the page, like above the files when you go to the home page. You can click like, it's just a bunch of numbers and letters, and you can click on those and then you can see a history, and then it's kind of a pain in the ass though, to like go back and revert all the code, because you may get rid of like changes. So yeah. And then git reset dash hard. It's not really useful outside of workshops, to be honest, like because it removes all of the current files that you're doing. So you may lose all of your work that way. I mean, if you do git reset dash hard and lose all of your local work, there is no getting it back unless you have like Control Z on your VSCode or something. But git commit dash amend. Generally, you don't want to amend commits that you've already pushed. So this would be like, it's any changes, like once you commit it, you would add new things onto it or change your commit message. Unless you're like, the only time I've ever amended things is if like I've misspelled a comment and like a person was like, oh, you should change this. And it generally like you only want to amend when whatever changes you're doing already would fit in that commit. And generally like you just want to make a new commit instead. And then more useful git commands, git stash. So if you have like current changes and you want to pull, and it's like being like, oh, like you got to push your current changes before you pull, you can do git stash, and that will just like put away your local changes, and you can just store them somewhere else, and then you'll be on the current working version of the repository, whatever branch you're on. And then you can do git stash pop to put those changes back on where you're at. That may lead to some like local merge conflicts that you need to do. But if that's useful if you're ever in that situation. And this is useful for when you're changing branches back and forth. Like let's say like you're working on like a feature on one branch, and then you have a bunch of changes that you want to do. Then you stash the changes away, and then you can change branches to see like what your teammates are doing if you want to see that. And then you can pop it back, and then you can change back to the branch and pop it back on. Git branch. We use git checkout-b. I don't ever use really the git branch, like actual syntax. But branching is super, super important in Git. It just like whenever you're working on a new feature, generally what you want to do is make a branch of the main branch or master or whatever it's called, your repository, and then just like name the branch like the actual like name of the feature that you're working on. So like if I was adding like Catholic like messages, I would just like say, okay, messages. Make a new branch from main. It's called like messages, or something similar to that. So it's super important. And then you can also like when I'm talking about pull requests are in GitHub, but they're merging two branches together. So like if you want to merge one of the features into like main or master, you'll create a pull request, and then you can do that. They're kind of complicated. Well, not super complicated, but they're hard to get your head around when you're first doing them. Like I still kind of struggle with them sometimes, but it's like when like the general like base concept is pretty simple. But moving on to like how to do all of this in VSCode, because personally I don't like terminal, but you can do all of this locally in VSCode. So if you're on this is like on the left side of VSCode on the left tab. You'll see like all of this like file, whatever search. So it's the third one down. And when you click on this, usually when you're editing, like maybe your workshops, you've seen this, like this like the numbers here. The one I always use is source control. That's like by far the most important one. Like you can go through all of these and see what they do, but I've never had to use them. So you can see here, like you can see the changes that you've already made. You can also see like there's like if you're doing some stuff with staged and unstaged changes. Unstaged just means that you add them to commit, and you can see all the differences there. You can also click on the individual files on here, and then you can see the diff. And that's the equivalent of git diff, and it'll pop up in your main window. You can also, and you can see here that you can add the source control, like a commit message, and then you can commit on that arrow on that drop down menu. There's like a commit and push, and like a commit and sync as well. So sync just means that you're pulling and pushing at the same time. And you can, and then going down all the way, you can see like next to the kind of two brackets next to each other on the bottom left, you can see like the name of the branch. You can also click on that to change branch, and that'll pop up with like a dialog window in the search bar. You can also create a new branch that way. And then the two arrows that are going in a circle, that'll show up like next to it will show up like how many commits that you, like it'll be a down arrow, then a number, and that's like how many commits have been pushed without you pulling. And then there's an up arrow will be to the right of that, and that's the number of commits that like you've done but haven't pushed yet to the repository. You can also do work through merge commits or merge requests on here. Merge conflicts, sorry, and then like you'll be able to like do the diff and like do all that. But that's like another thing for Friday. So I generally use VS Code. If you don't like either of those, you can also use the GitHub desktop app. And the website. The GitHub desktop app is super friendly to use, very intuitive. I use it sometimes for running repos when I don't want to deal with all the Git clone stuff. So here's some other Git tools. And then now going to like actual code formatting and style, right? So for web development and JavaScript, and in HTML, this is very useful for HTML. It's a VS Code extension, which you can access. VS Code extensions, I believe, are the 5th one down or something like that, but you can access it on the left side of VS Code to like the extension store. And so this just like, you have to also format unsafe. This is in VS Code options that you can just look up. And so it automatically formats and like use white space and like stuff like that to make the code pretty. The one thing that you want to avoid though, is you want to, this goes for basically all style guidelines, but you want to decide as a team if you're going to do something or not. And so like if one person uses prettier and the other person doesn't, it's going to lead to really bad merge conflicts where you have the same code, but they're different white space. And so it's going to be like pain in the ass to like actually like move it around and like do all that. So you can see here an example of that. So like they're auto formatting with prettier, and then like another person isn't using prettier, and then there's also a merge conflict and like they also commit. So yeah, like I used it when I was taking web lab. It's generally like really useful, especially for HTML, because it'll just make your code a lot more readable with white space. By white space, I mean like tabs and spaces anywhere there's not characters. So looking into different like tools. So there's also, like I was mentioning before, you don't like, you should know how to use terminal, but like you don't absolutely have to. You can always just look up the commands. There's also like Git cheat sheets if you look those up online. I've never, like I have both of these installed, but I've never really used them. So there's like Git graph, which is on the right side here. You can see like all the commits and branches. Like each of these colors represent different branches, and you can see like where they are. This is kind of hard to understand for me. I don't like it. And so like, but if it clicks for you, then it's pretty useful. GitLens is just like an upgrade of the current like VS Code extension, or like the VS Code inbuilt support. I probably use GitLens without realizing it. So I would recommend that you just have GitLens because it's like a very widely known and used extension. Maybe a different editor too, like VS Code may not like VS Code, whatever, for whatever reason. I personally like it a lot, but one thing that people use for WebStorm, or people use for web development is WebStorm. I never personally used it, but the person who did How to Code Git last year was a big fan of it, so I wanted to do it for his sake. So they can, like, you can see here, there's some pros and cons for everything. So, and then also, like, you can see, like, if you're adding more stuff on, then you need a better machine to handle it, better computer to handle it, and then it can also be confusing. And then Vim is like the classic like software engineer, like stereotypical like text editor. it has a really large, like big learning curve. But the main thing is that like it doesn't really have a lot of mouse support. It doesn't really have an intuitive like user interface, but it allows for shortcuts, and you can do some like a lot of things faster, or like a lot of things at the same pace or faster than VS Code. It's mainly a single keyboard shortcuts. And also TypeScript. TypeScript is like the standard for professional web development. I would hope if you're going to work at a company that they use TypeScript. The only difference between TypeScript and JavaScript is that each variable that you declare has to have a type associated with it. So like if you're declaring a string, you have to do like const string or str like with it and then the name. And so that's something called static typing, if any of you are familiar with that. But it's not like, I say that, but like buzzword, it's like super big. But if you're going to take like future classes in CS, you'll hear about this. TypeScript 6031 is in TypeScript as well. So this is something that like to be aware of. You don't necessarily have to use it for web lab. All right, so now going into like actual more style, writing quality code. So quality code is better than just getting code out. And for all of the reasons I've described before. But like I mentioned, also the best style is the one that your team agrees on. It may not be objectively the best, you may disagree with it. I mean, it's so important to get your voice heard, but if your team wants to do something and you know it's not like horrible, then you should do it. Like if it's exploding your repo like literally, then like you may want to like object and not do it. But like you have to make some compromises when you're working with a team. But yeah, it's like you just want to agree with your team and then move on. And then also just a general rule of thumb, like in most cases, having to use bad code for your website to work or like kind of skip steps with stuff like that would be like hacky, which I'll explain later, as a result of bad design. And design here meaning system design, not like UI or stuff like that. We'll go into that more in a bit. And then here's some more on design, like the React component hierarchy. You want to, this is kind of doing your skeleton along with that, but like the React component hierarchy is your general, like how you want your file hierarchy to look in your repository. But this is really important for just planning out your website before you do it, and then having it to go from. And so like what you can do here is you may be able to combine components into like one thing or use the same general page if you want, like, and then just use like specialized versions of like a class or something. And you can also plan out like who's going to do what. So this is just really important to know and have. Mongo schemas, you all have experience with databases now. So you can see like the Mongo schemas are just like types for each variable. And then it's just also important to have so that the front and back end people can work together well and plan out. And then API specifications. Like I was talking about with the API lecture, you want to have set types and like what you're expecting with your pre and post conditions for your API. And so this is good to just decide as a team before you start coding your website so that you have a plan. And then all this can be done with Figma. Figma is awesome. And like you can see like all the messages like going across here. I'm not sure exactly if Figma can actually do like the API specifications, I guess, but like it's good to also see like if you want to integrate with front ends, you can see like what everything will look like and where specific components will go. Right. So like I was kind of hinting to, you don't have any design, you don't know what you're making. And it's really good to just execute on a design idea. Most of the work will come from the design beforehand. And then you're just executing on the idea. You don't want to figure out the design as you go. You'll just get confused. And then you'll probably get less done if you immediately start coding versus versus a team that planned out their website really well and then can just execute on that plan for like 2 weeks or however long they're coding. Because you'll eventually run into some problems that we'll discuss if you just start coding. So let's say like you want to add a new feature, but your code base is kind of bad. And it's like it's not really making sense in your head. It's like I have to do a bunch of stuff, unnecessary stuff to do this. This shouldn't be this complicated. So you have two options. You can refactor your code, which will take a lot more upfront time, but will ultimately make your code better. Or come up with a hacky solution, which only takes 30 minutes. and kind of just like adding random things to make it work that seem unnecessary, but you still have to do to not get an error. And so what I mean by hacky code, it's like code may be hacky if it's super inefficient, right? So if you're doing like a bunch of for loops, or like you're doing a lot of API requests that you may not need to do, it's unintuitive to implement. So when you're explaining it to someone or explaining it to yourself, it may be like, okay, but then I have to make this API call for no reason, and then, or like I have to set the state for no reason, and then it's very buggy. And then also, if it violates like the preconditions of the library, and by that I mean, like if you're including like a function arguments, like you have to do some like weird like variable or like type switching to like plug into a library, you're probably not integrated with that library well enough with your code, and you should have designed better around it. And there's also a lot more stuff, but generally it's more of an intuitive sense, right? So what you want to do, like I was saying, is design from the start, avoid the need for hacks at all. Do all of the stuff that I was saying, and then you want to plan out and discuss your changes with your team before, during, and after. It's important to keep an ongoing dialogue for everything that you're doing when you're designing a website, because based on your implementation, your design might change and vice versa, right? So just be sure that like if there's one thing I want to like take away from this lecture, communicate with your team and do it often. And specifically API specification, you want to ask yourself like these questions. You can review the slides, but generally like get a post, like what parameters, whether data types, does it change? Generally this is stuff that we ask like in the API. So like I've also found that generally like, so whenever you design a front end, your API follows. And this is also something I said in the workshop, right? So we've been talking about like clean code and like code style and all this. Let's make a definition of clean code. So here are some principles. These are also taught in 603.1, a very useful class. I mean, if you're 6.3, anything like that, kind of go to computer science. All right, so the main thing is dry. Don't repeat yourself. Repeating code anywhere, you want to actually put it in a function, even if it may be like, and also like if you know like if there's like a specific like 1 or 2 lines that are like different, you generally want to be like, okay, how could I generalize this? You want to make things as general as possible, and then specialize them for each specific use that you want to use in your code. And then for actually designing functions, they should only do one thing generally. Like one thing that I used to do a lot when I was designing functions is like a Boolean, like just a true false like thing that would have different behavior based on like if it was true or false. And that should have been 2 functions. So you want to make your functions as simple as possible. And then what I was saying about the pre and post conditions, those are called specifications. What inputs does it take? What does it assume about those inputs? And then what does your function return? What does it assume about those? And then just keep it simple, right? Another thing, I didn't learn this until the spring in 603.1, magic numbers. So magic numbers are numbers that appear out of nowhere. You can see here, like if you're reading through this code, you have like say like you're doing an area of rectangle, and then there's just a 60 somewhere for no reason. And it's like, where'd that come from? And so the reason why you want to avoid magic numbers is because like if you're using constants generally, you want like it goes with the principle that like you should make everything as generalized as possible, because you may want to change those constants for testing, or just like in the future like things may change. But instead of having the 60 here, what you want to do is like have an accurate and meaningful variable name. And so that would mean just like, I don't know, you could name it like rectangle area multiplier or something like similar to that. Right. So we'll go into those now. So like good variable names, correctly describes what your variable does. It doesn't imply any like side effects that the variable like might do, or like it's used somewhere that's not like intended to be. So like generally, like if you have like, let's say like going back to this example, if you had 2 60s that did different things in different parts of your code, then you want to name them 2 different things, even though they're the same value. I mean, you may want to consider like combining those 2 and making a more general name, but yeah. Like so for example, this like say you need a variable to describe how many doors a room has, like you wouldn't want to just do the doors equals 2, you want to do like the number of doors in the room. And the reason why good variables are important, they help readability and remove the need to comment your code as much. And so we'll go into commenting code, right? later in this lecture. So another like notes when you're defining variables, this isn't so much naming, but always clear your variables in the low scope that they're needed. And meaning by that, like if you only use a variable in a for loop, then you want to declare it in the body of that for loop. And that solves a lot of problems. Like if you're using the same names for different variables, and like different meanings of variables, like in between functions or something like that. And then also like essentially this rule is like avoiding global variables like at all costs, because you will almost never need them. And if you need them for your code to work, it's bad design. You also always want to use const and this goes along with the principle too, like you always want to use immutable data types. Get more into that if you take more classes, but string like data types that cannot be changed so that people can't accidentally change them and then cause bugs. So if you know like for sure what a set like variable is, then it helps a lot with just removing bugs, right? So, and then also you want to agree on the naming convention with your team. We use camel case, generally web development use camel case and like JavaScript and stuff like that. But Python uses snake case, which is just underscore here, but you just want to agree on that. Like if you want to use camel case, it's probably the easiest one to use in this class, just so you're aware of that, right? And then like, let's say like you do this lecture right, you listen right, and then like, okay, but how do I actually determine like how janky my code is, right? So if you have, it's called code smell. Generally the symptoms of this are lots of copy pasted code, if there's that way too long, stuff that isn't used, variables that aren't used, functions that aren't used. It's hard to understand, like if you gave it to someone outside of your team, like a TA or something, and they're like reading through it, it's like, what is going on? And you have to explain it to them, then your code is not like enough to document it enough or design well enough to understand. It's hard to add new features, lots of bugs. Yeah, especially like random and unexpected ones. Like if you're like having like weird bugs that like you wouldn't expect, like I guess you never expect any bugs, but if it's like you have to dig through and it's like a specific part, then it's not great, right? So you can see some code smell here. This is my old code for my web lab project. You can see like I'm doing some weird stuff with magic numbers, like in line 169. I'm not really commenting at all. And it's like, okay, like you only get it if you know what the actual system's doing. And then we're gonna do big stinky code. This is old me, but here it is. So this is Nick's old code. You can see this is auto formatted with Prettier, I'm pretty sure. So this is his web lab project. You can see on the right side here, like the clear overview on the VSCode. See the massive block of red here. These comments are also not good. And this, like, you never want to do this. If you catch yourself doing like a big if statement, like there's a better way to do it. Go to TAs for help. It just takes way too much time. Like it's not good code. It's going to be super buggy and not maintainable at all. So if you ever catch yourself like doing like probably more than like 5 if statements, you can join office hours. We will find a way to generalize that, right? So this is like, and all of this is a more than like I guess part of a more general concept of technical debt or tech debt, as it's usually called. And this accumulates over time, which is a quick hack instead of a better general solution. And there are a lot of causes about this, like, you might not have time and you're kind of just like throwing everything together, which this class you will have to do that probably. And that's perfectly fine as long as you don't need to maintain it. And then you also have like laziness, like you can't think of a better solution or whatever, or you don't know about actual code style. And so here we'll go through an example of tech debt that will probably encounter in your actual app, right? So you start out with your app right now. You probably haven't coded a lot. You don't really have any features. You have a general idea of what you want to do. So right now you have 0 tech debt. You may have some from your design, but so you want to add a feature. So you're going to do that, right? So you have your feature. Okay. You think it works, great, but then like you may encounter like 1 or 2 bugs. So you're like, okay, let me patch those bugs. Let's add some if statements somewhere, make sure that it works. Okay, but it's a hacky solution. It probably should have worked from the start. unless you didn't think of a special case or something while you were designing, in which case you want to like reiterate your design and then design it correctly from the start. But by doing that, you've also started to accumulate tech debt. And you can keep going on and add this, and adding features and hacks and to make them work together until eventually like we're back to the situation that we encountered earlier, where you want to add a new feature, but it's too buggy to add, and so you need to refactor your code. Also, a quick definition of refactor, because I forgot to include that. Refactor your code just means like you reiterating on your design and code to where you're basically just rewriting it in a better way. And you go from existing code, make it better, and then it generally hopefully has the same behavior as your old code or better behavior. All right, so we're refactoring, and we get rid of tech debt. Well, most of it. There'll probably be some. It's almost unavoidable to have some unless you have like unlimited time and manpower. And so paying off technical debt, right? So it accrues interest over time, and just would have been easier and saved you a lot more time to just do it the right way from the start. Because all this time refactoring and debugging you would have probably saved like 50, like let's say like you spent like 20 hours debugging, then you probably would have just spent like 5 hours actually making a good design. And so like I said earlier, this is extremely important for project things to be maintained, like things with an unlimited lifespan. So generally like companies, this is very important. This may not be actually like, companies may not have good coding practices though. They vary a lot. So when you actually like, if you're going to like work, you may be very surprised. Like in my first company, there were no code reviews, which is also really bad. So and like some companies will have better code practices than others, and you want to choose the companies that have good coding practices. But like for this is basically like a long hackathon. So like if you have limited time, then tech debt doesn't really matter as much. As long as your website like works, then like it's good. But it's good to know about it, so then you know how to bend the rules a little bit when you're coding. And then we'll just moving on to comments here, and how to comment your code. So looking at these two, I'll give you a second to read it. But these are both API methods. So the left side has a lot more comments, like it explains a lot more, but then the right side has just the code. So I guess like generally like just make a decision on which one is better right now. And then I'll tell you, in my opinion, which one is better. I'll give you like 10 seconds or something. Okay, raise your hand if you think the left version is better. Okay, hands down. Raise your hand if the right version is better. Okay, I generally say the right one is better. So the reason why is because on the right version, you have to assume that whoever's reading your code knows how to read code and like knows how to code. And so if a person knows how to code is reading this, then it's pretty self-explanatory what they're doing, and they know all of like what they're doing. Now, not like the initial like reaction is to say like, oh, like the more comments the better, but like comments are for explaining like why you coded something the way you did and not how you did it. And if you assume that everyone's like a qualified reader of code, then this makes sense, because the code like is self-explanatory itself. Like, and by writing a lot more comments than you need, then you're wasting your time and also the reader's time, because you're just putting extra effort into something that's meaningless. And also may mislead the reader, because like maybe like the code actually doesn't do what you think it does, and there's a bug, and it's like, okay, well they say it's doing this, but it's actually doing this. Why is that? So it's a failure, right? So we'll go to example code here and give you a second to read through it as well, and then I'll also ask you to put hands up. So do you think that you should add comments to this code? I'm gonna be like 10 more seconds. And also, this is kind of hard code to understand. It took me longer than 10 seconds. Just like briefly skim through it. But this is, it's doing requests to an API and then awaiting some promises and stuff like that. So Okay. Sorry about that. Go back to where we were. Oh, wait, this is part 2. Sorry. Okay, you're not supposed to see this. Okay. Yeah. So when you have a code like this, like just ask yourself, like, if I can rename my variables or comments necessary. So here are some examples of like clear function names as well. And I like this also applies to the variable names. You want your function names to be like clear and concise, like exactly what they're doing. So like if you have like a load message history, it's doing exactly that. It's doing nothing more. You have add messages like set active user. These are all great examples of small functions that just do that and then nothing more. And they're very simple as a result. Here are some other ways to document your code. These will help, especially with React components, because React components are kind of hard to name because you want like a actual visual representation of what they're doing. Then also it's also really hard to mix like when you're explaining the code. So JS doc strings, you can, and these are like generally like more, you have like doc strings like with the inputs and outputs. So you want to add these to all of your like React components as well. So like you want to have a description and then you have a prop types. So you can do like an app param and then in the brackets is the data type that it actually is. And the variable name and then its description. And so this is really good. Like there's no way to actually tell what props are being passed through without you knowing, or looking at like the component above it in the hierarchy. So this is really good for just like you're able to look at one file and just see, and also like copy pasting. Like I said, like API documentation, you want to have that. Database schemas, you also want to have that. But this is all part of documentation. This is very important for like when you want to maintain code. I mean, another way of doing documentation is just like having like if you, let's say you have a messenger group chat, like everyone knows, or like you take a pic, like you write it on a whiteboard sometime, like a stud or something, and then you just take a picture and then post it there. You just want to have everyone knowing on the team what like all of these do, and you want to have it readily accessible for them. And then this is like just part 1. That's all we have for today. I think I'm probably going over. Sorry vividly, but part 2 will be Friday at 11 a.m. I'll cover testing, how to go through like full merge requests, and then I can also like answer any questions that you guys have there. So and then Nick will come up to give some announcements as well.